Hey guys, so we're still in section 4.7. I'm on page 413, so we're almost done. You're almost done with the whole book even, so let's jump into this. Okay, so we've been talking a whole lot about the vertex formula, so I want you to actually find the vertex of this function here. And just to give you a little bit of a hint, so in this case, my a would be 1. So notice that there is no b, so my b would just be equal to 0. So I want you to find the vertex of this and then hit play when you're ready. Okay, so if I calculate negative b over 2a, this will equal negative 0 over 2 times 1, so this just equals 0. So there's the x part of my coordinate. And then if I plug that into the function, so I get 0, this will be 0 plus 2, so this just equals 2. So my vertex is the point 0, 2. So I'll mark that here. So now what I want you to do is the same thing we've been doing for graphing. So select 2 points to the left and 2 points to the right, and then actually graph the function. Hit play when you're ready. Okay, so here's my x, here's my y. So 2 points to the left, this would be like negative 1 and negative 2. And 2 points to the right, this would be like 1 and 2. And if I plug those in, so let's see, at 1, this will just be 1 plus 2, so this will be 3. At negative 2, this will be 4 plus 2, so this is 6, and then this will still be 3, and this will still be 6. So let's see, here's 1 point, and then here's the other one, 1, 2, 3, 4, 5, 6. So I'll just mark this up on each side. Okay, so here's my parabola, and I want to notice something with this. Does the graph have any x-intercepts? So x-intercepts would mean that it intersects the x-axis. So this does not. So we can see that this graph doesn't have any x-intercepts. So now I want to think about this for a second. What would happen if we tried to calculate the x-intercepts? So on the last pages, we were finding all kinds of crazy x-intercepts, right? So all I want to do with this is I just want to find the x-intercepts of this equation here. So to do that, I need to set this equation equal to 0. So let's take a look at what happens when we do that. So we have x squared plus 2 equals 0. Okay, so notice that I can use the square root property to figure this out. I can't factor it, but I don't have another x, right? I just have x squared. So if you have just x squared, then you can go ahead and use the square root property. So notice what happens if I try to do this. I subtract 2 from each side, so I get x squared equals negative 2. And now if I try to take the square root, so if I try x equals plus or minus the square root of negative 2, so if you try plugging that into your calculator, just try plugging in, so just plug in the square root of negative 2. So I've got my little handy dandy calculator next to me. Mine says domain error. Yours might say something else. It'll tell you something about an error. So this is what this means then. So look at what we tried to do. We tried to find the x-intercepts, but we already know that it doesn't have any x-intercepts. So if I didn't know that, if I didn't know what the graph looked like and I was just trying to find the x-intercepts, what would happen? I would get an error, and so it's just now knowing how to interpret this. This doesn't mean that we did anything wrong. When this happens and we get a domain error, this just means there are no x-intercepts. That's what that means. So how should we generalize this? So as you're kind of working through this, so what's going to happen is that you're going to get something. You're going to know that something's up because you can't factor it. So if you could factor it, then it would have x-intercepts. So it won't be factorable. So you'll get a result then that you will either have to use the quadratic equation on or the square root property on. And you will basically get a negative under the square root of either one of those techniques. And when that happens, that means you have no x-intercepts. So that's how you would interpret that. Okay, so I've got one last problem here, and then we're good in this section. So an athlete's event is the shotput release. When the shot is released at an angle of 35 degrees, its height, f of x, in feet can be modeled by this equation, where x is the shot's horizontal distance in feet from its point of release. Okay, so with this type of problem, so let's just kind of see what we've got here. This is a quadratic, right? This is going to be a parabola. So first of all, just thinking about this, is this parabola, is it going to open up or down? It's got to open down because my A is equal to negative 0.01. This is negative, so when it's negative, it opens down. So it's asking for what is the maximum height of this shot put. So what is this really asking for then? It's just asking for the highest point. So what you have to do here is you just have to find the vertex. And we can do that by, so I've already said what my A is. My A is negative 0.1. So maybe I'll just state what my B is. My B is 0.5. So I can now find the vertex. So if I do this, I can take negative B over 2A. So this is negative 0.5 over 2 times negative 0.1. So if I work this out, I get 25. Now, if you didn't get that in your calculator, just a pro tip, make sure that you put parentheses around the denominator when you're plugging that into your calculator. Okay, so now I have to plug 25 into this function, so I'll probably want to use my calculator to help me out with that. So this will be f of 25, so I have to plug in all of this, so 0.5 times 25 plus 5.8. So if I plug that all into my calculator, I will get, so if I plug all of this in, I get 12.05. Okay, so now you just got to go back and actually remember, what are you being asked? So what is the maximum height? So now what part of this function represents height? Well, if I go back to this, it says its height f of x. So by plugging 25 into this, this actually gives me the height. So this is the height. So this will be 12.05 feet in height. So this is your maximum height right here. Okay, now it says how much horizontal distance has the shot put traveled when it reaches its maximum height. So remember, x is, so if I look at this, x is the shot's horizontal distance, so that would be this part that we found here from the vertex. So thankfully we don't have to do anything for this. This will just be 25 feet. And now for the tough one. When the shot put hits the ground, how much horizontal distance has it traveled? So remember, you've got this shot put, you've thrown it, and then it's going to hit the ground. So f of x is modeling how high, like the height of the shot put. So when it hits the ground, what is the actual height of this shot put then? The height would now be 0, right? It's hit the ground. So if I actually write that out, I want to set this equation equal to 0, like this. And so I take this and I set it equal to 0. So now this is what I've actually got to figure out. So this is basically, once again, finding X-intercepts. And so now just by looking at this, well, let's see what we can actually do. So I could try clearing the decimals out of this, and maybe that will just make it nicer to look at. So you could either just plow ahead with the quadratic formula, or you could try clearing the decimals. So if I do that, so let's see. Let's just go ahead and play around with this for a moment. So I'm going to move all my decimals just over 2 spots just to see what I get. So I get negative x squared plus 50x plus 580. And this is all still going to equal 0. That's not going to change. So you can kind of see this isn't going to really factor that nicely. So you can either use, like I said, decimals, or you can use whole numbers, whichever you prefer, to actually do the quadratic equation. So in this case, so my A is equal to -1, my B will be equal to 50, and my C will equal 580. Or if you do decimals, that's fine too. And so now from here, so let's see, I've got my x equals -b plus or minus the square root of b squared minus 4ac, all of this divided by 2a. So let's go ahead and plug all of this in. So one more little practice with the quadratic formula. Let's see, I've got all of this plugged in, all of this divided by 2 times -1. Okay, so I'm going to continue my work over here. So let's see, this is -50 plus or minus the square root of, so this will come out to 2,500 plus 2,320. All of this divided by -2. So now I get, let's see, -50 plus or minus the square root of 4,820 divided by -2. And so now I can break this up into two cases. So I get x equals -50 plus the square root of 4,820 divided by -2, or I get x equals -50 minus the square root of 4,820 divided by -2. So let's work this out. So for this first one, if I work this all out, I get -9.71. Maybe I'll round that, -9.71. And then for the second one, I get +59.7. Okay, and now you've actually got to take a moment and say, what was I trying to do? So we're trying to figure out this x-intercept. So we need really the x-coordinate, but we're trying to view this as horizontal distance. So when you look at these two values, this one here does not make sense because distance can't be negative. So the horizontal distance is this one here, this 59.7. So it travels, so maybe I'll just write this here, it travels 59.7 feet. That would be its total horizontal distance. Okay, and that wraps up this section. So we have just one more section left. I'll see you guys there.